All right, now let's go over the inscribed triangle theorem. The inscribed angle theorem. We already know by this point an inscribed angle is an angle that has points on the center on the circle's circumference. So that means BCA will be our inscribed angle. We already know at this point a central angle is an angle with vertexes in the center. So BOA will be our central angle. The central angle, the degree measure, will always be 2 times the size of the inscribed angle, right? So this theorem states that if BCA is our inscribed angle, then half of BOA would be equal to BCA. So it says the measure of an inscribed angle is half the measure of the central angle that defines the same arc. So you notice that this arc BA or AB is shared by BOA and BCA. However, we see clearly that this opening for BOA is wider than the opening for BCA. So all it does is, if we took a picture of it and dragged it, we're dragging this angle further back, which makes it close more than the central angle. All right, so here's an example for the inscribed angle theorem. We have BOA, which is equal to 160 degrees. BCA is what we're looking for. Since we do understand that BCA is the inscribed angle is half the size of the central angle. So in this situation, we will have half of BOA, right? So that means all we're going to do is take 160 and divide it by 2, right? For this situation, you can do it in the calculator. You can do it by head if you would like to. We know that 16 divided by 2 is 8. So that means 16 divided by 2 is 8. So our answer here would be 80 degrees. So BCA will be equal to 80 degrees.